Okay guys, our lesson today is to be able to find the volume of a prism. Volume by definition is a measure of the amount of space that a figure occupies. Volume will always be measured in cubic units. Right? When we think about volume, we want to think about the number of cubic units it takes to fill a container. Right? How many cubes would I be able to fit, right, inside of this container? Okay, right, that's what we're thinking about with volume. How many cubes would it take? Let's erase that. Okay, when we find volume, we use the following formula. First, we find the area of the base, and then we multiply that base area times the height. We use the capital B to represent the area of the base, and we use the lowercase h to represent the height of the prism. Right? The base area, right, if it's a rectangular prism, right, the base area would be the area of a rectangle. If we're looking at a triangular prism, the base area would be this triangular shape down here. Alright, let's go to the next page. So we want to find the volume of this prism. We want to first start with our formula. Volume is going to be equal to the base area, which we use a capital B to represent that base area, times the height. Now let's look at the prism. When we look at the base area, we see that the base is the shape of a rectangle whose length is 6 and whose width is 8. So when we find that base area, we're going to multiply the length times the width. So it's going to be 6 times the 8. And then we have to multiply that base area, I'll change colors here, that base area times, right, the height. The height would be the height of the prism as it sits on its base. Right? And that height here is going to be 15. Now another way of writing this formula is simply volume of a rectangular prism is going to be equal to the length times the width times the height, because the length times width represents that base area, capital B, and then the h represents the height of the prism. So you can write the formula either one of these two ways. You can write the formula as base area times height, or you can write the formula as length times width times height. Either way, you're going to get the same answer. Right? 6 times 8 is going to be 48, and 48 times 15, that volume is going to be equal to 720. And the units for volume will be cubic yards. Right? So make sure that you're using an exponent of 3 when we write our units for volume. Okay? Let's try another example. Here we're asked to find the volume of the prism, but we're looking at a triangular prism, right? Not a rectangular prism. Still want to write the formula as base area times the height, but the base area here is a triangle. All right? But Mr. Pilata, how come this rectangle down here? Right? How come that's not the base? Well, the base by definition of a prism, let me undo that. The base by definition of a prism are the two parallel congruent faces. So the two parallel congruent faces are going to be the two triangular faces. Right? That rectangular base down here, which I'm filling in red, right? That rectangular base does not have a parallel congruent face up top here. All right? So that is why we call this a triangular prism, because the two parallel congruent faces, which are bases, are triangles. Okay? Well, we start with our base area. Our base area is the area of this triangular face here. And our base area is in the form of a triangle, and that's going to be 1/2 base times height. But then we have to multiply.
Okay.
But then we have to multiply by the height of the triangle here. All right, and the height of the triangle is going to be, let's see, 2 inches. So times the height of the triangle, right? So volume is going to be equal to 1/2. Base and height of the triangle is going to be 5.5 times 2. That's going to be 5.5 times the 2. But then we have to multiply by the height of the prism as it sits on its base. That's what this H is here, right? The H here is this red segment here. So you have to imagine the prism sitting on its triangular base, and we need the height of the prism as it sits on its base. So that H is going to be the 4 inches, right? So I know we have two different H's there, and that's a little confusing, right? This first H is the height of the triangle. The second H is the height of the prism as it sits on its base, all right? We multiply those values and we wind up with the volume is going to be equal to 22 cubic inches. All right, volume should be in cubic units. All right. Okay, let's continue. Now this next page allows you guys to try a couple of problems on your own. You may want to stop the video and try them on your own. Right? If not, take a look and we'll do a couple more examples here. Volume is going to be equal to base area times the height. Volume is going to be equal to the base area is going to be the length times the width. Length times the width. So that's going to be 4 times 4. And then we multiply that by the height of the prism as it sits on that base. So it's going to be another 4. So the volume is going to be equal to 4 times 4 times 4, which would be 64 cubic feet.
Four-wheel drive. Also, would you like to hear more?
All right, let's try another one. Volume is going to be equal to base area times the height. Volume is going to be equal to the area of the base, right? Base area times the height. So that base area is going to be 1/2 base times the height of the triangle, but then we have to multiply by the height of the prism as it sits on its base. So it's going to be our other H. So volume is going to be equal to 1/2 of 12 times 5, and then we have to multiply by the height of the prism times 9. Now those of you that are having some confusion here, we can make it a little bit easier here, especially if you're given 3 numbers, right? The volume of a triangular prism is going to be 1/2 of this number times this number times this number, whereas volume of a rectangular prism is simply length times width times height. The volume of the triangular prism is simply going to be 1/2 length times width times height. Right? That might make it a little bit easier for you guys to remember. Volume is going to be equal to 270 cubic meters. All right. All right. A couple more examples here. A movie theater designs 2 bags of popcorn that hold 96 cubic inches. Problem A, find the height of each bag. Problem B, which bag should the other choose to reduce the amount of paper needed, and explain your answer. Okay, well first we want to find the volume of each bag. So let's start with bag A. Volume is going to be equal to length times width times height, or you can use the base area times height. Volume is going to be equal to, let's see, well we're given the volume, right? So let's cross that out. All right, we're given the volume here. We're told that the volume is 96 cubic inches. So we want to replace that V with 96. Our length and width are going to be 3 and 4. Right, and we're asked to find here the height. So we have 96 is going to be equal to 12 times h. When we divide both sides by 12, we wind up with 8 inches is equal to the height of that first bag. Try that for the second bag. Volume is going to be length times width times height. Volume is going to be equal to, let's see, what's that going to be? 4 times 4 times h. All right, we're replacing V with 96. So we have 96 is going to be equal to 16 times h. Divide both sides by 16. Wind up at 6 inches is going to be equal to the height of the second bag. Question B asks, which bag should the theater choose to reduce the amount of paper needed? Okay, well, to figure that out, we have to find the surface area of each bag, right? Because if we're looking for how much paper each bag is going to need, we need the surface area. Okay, so let's start with, let's call this bag 1, let's call this bag 2. So surface area 1, we'll make that a little 1. Surface area 1 is going to be equal to 2 times length times width plus 2 times length times height plus 2 times width times height if we're looking for the surface area. Now, because we have an opening at the top of the bag, let's show that here, right? We have an opening, so we don't need paper for that surface. So that's one of our length times width rectangles. So I'm going to cross out this 2, and that's only going to be 1L times W because we don't have paper up here, right? That's open. So if I want to find the surface area of that first bag, surface area 1, that's going to be 3 times 4. And we know that the h is 8, so that's going to be 8 plus 2 times 4 times 8 plus 2 times width times height is going to be 3 times 8. So surface area 1 is going to be equal to 12 plus 64 plus 48. Surface area 1 is going to be equal to 124. And those are square inches because we're talking about surface area. Surface area 2, write that over here. Surface area 2, same formula, 2 times length times width plus 2 times length times height plus 2 times width times height. I'm going to cross out one of those 2's because once again for bag 2, showed up here, right, we have this open section. So I don't need 2 times the length times width, I only need 1 times the length times width because of that opening. I'm going to have some place to put the popcorn. So that's going to be 4 times 4 for the length and width. Right, and we know this h is going to be 6, all right, so it's 6 for the h, plus 2 times 4 times 6, plus 2 times width times height is going to be 4 times 6. So surface area 2 is equal to, what's that, 16 plus 48 plus 48. So surface area 2 is going to be equal to 112 square inches. So if we are making these bags of popcorn as a company and we want to be able to give 90 or have a volume of 96 cubic inches for our popcorn, but we want to use less paper for that 96 cubic inches, right, we would choose bag number 2, right? So for part B, we want to find bag number 2 because bag number 2 uses less paper than bag number 1 because it has a lower surface area. Okay? All right, last problem. says you design a third bag that has a volume of 96 cubic inches. Should the theater in example 3 choose your bag and explain your answer? All right, so let's look at this third bag. All right, first we have to find the height. So we start with our volume formula. Volume is going to be length times width times height. We know that the volume is still going to be 96. The length times width is going to be 4 times 4.8, right? Because here's our length, width, and our h. So we have 4 times 4.8 times our h. We don't know what that is. So 96 is going to be equal to, what's that, 19.2 times h. Divide by 19.2. And we wind up with an h of 5 inches. So now we have a bag that has the same volume, still 96 cubic inches, so we'll still be able to hold the same amount of popcorn, but now we have 5 for our height, 4 for our width, and 4.8 for our length. So let's find how much paper will that bag use with those dimensions. So surface area is going to be equal to 2 times length times width plus 2 times length times height plus 2 times width times height. So our surface area is going to be equal to, cross out one of those 2's because once again this bag has an opening at the top, so we don't need 2 times length times width, we just need 1. Alright, so that's going to be length times width is going to be the 4.8 times the 4 plus 2 times length times height, that's going to be 4.8 times the height of 5 plus 2 times width times height, that's going to be 4 times 5. So the surface area is going to be equal to, what's that, 19.2 plus 48 plus 40. We add all that together, we get a surface area of 107.2 square inches. So which bag should we use to have the smaller or the same volume but less surface area? Well, if we look at this third bag here, it had a surface area of 107.2 square inches, right? So that is even less paper than the previous problem, right? Here we had 112 square inches and 124 square inches of paper. Bag number 3, we have 107.2 square inches of paper. So the theater should choose bag 3 if we want to use the smaller amount or lesser amount of paper. All right. Now, just remember, when you're finding the volume of rectangular prisms, let's go back to the volume here. When we're finding volume of rectangular prisms, it's rather simple. It's simply length times width times height, or base area times height. With a triangular prism, it's length times width times height, but we need 1/2 of that. All right, it's 1/2 of the base area, which is going to be base times height, times the height of the triangular prism. All right, I hope that's been helpful, and we'll see you soon.